All right, we've talked about polygons. Does anyone remember what a polygon is? Could you describe what it means, Mia?
It's a six, face shape.
It's a shape, yep.
With 6 faces.
Not necessarily 6.
But 5 or 6.
Okay.
It's a shape, but the spaces can all be a different size.
Okay, so a polygon is any closed figure. So it's any 2D figure. So a rectangle is a polygon. A triangle is a polygon. A hexagon is a polygon. Okay? So it's just flat shapes, basically. So we're going to be talking about drawing those flat shapes in the coordinate plane. All right, here we go. The first task is draw a polygon in the coordinate plane. Now you have graph paper for your notebook. If you don't, just sketch out a little graph on lined paper. So the first part of this is going to be drawing a polygon by plotting the vertices using ordered pairs, right? Part of a polygon is that it has to be, like I said, a closed figure. So once you plot the vertices, which is the plural for the vertexes, then you connect the points with lines. So it'll look like a shape. For example, draw the polygon with the vertices -1, 1, 0, 6, 4, 5, and 5, -2. Go ahead and sketch this in your notes. Sketch this in your notes, and then I'll put it up on the board so you can check your work. See what shape you get. Let's start by plotting point A. -1, 1. That means I go left 1 and up 1. So my first point is right here. Point A. Point B is 0, 6. That means I go 0 left to right. So I'm going to stay on my y-axis. And I go up 6. So point B is right here on my axis. Point C is at 4, 5. So I'll go 4 to the right and up 5. So somewhere about right here. And point D is at 5, -2. So 5 to the right, down 2. Okay. Then, once I've plotted the vertices, in order to make this a polygon, I need to connect them with lines so that it's a closed shape. Okay? So I'm going to connect them with straight lines, like dot to dot. Okay, so we get kind of a quadrilateral for sure, 4-sided. Kind of looks like a kite maybe, right? All right, so that's our first task here. It's just being able to draw a polygon by plotting the points, okay? Now this is what we were doing on Friday, to find the distance between points in the coordinate plane, right? This is where we were doing the collect the coconuts, and you'd go from one island to another because you had to figure out the distance between one and another. All right, so here's the rule, and we talked about this a bit as we were figuring this out on Friday. If 2 points are in the same quadrant, so if they're both in Q1 or if they're both in Q3, if they're in the same quadrant, the rule is this. Take the absolute value of the coordinates you're using. Remember when we did this, we would have 2 coordinates that were exactly the same, right? It would be like 10, 7 and 10, 4, right? We always had one coordinate was the same for both because it was a straight line. So then the other coordinate, we take the absolute value of the other coordinates, so the ones that are different. And what do we do? Do you remember? Subtract. Subtract the bigger minus the smaller absolute value. And that'll tell us the distance between the points, as long as they're in the same quadrant. So it's all about absolute value here because it's about distance, right? Remember we said that absolute value is distance. All right, so same quadrant, absolute value, and subtract. Actually, let me move this back so that you guys can stay with me. If the points are in different quadrants, so if you have to cross an axis to go from one point to another, so say if you're going from Q1 all the way down to Q4, if they're in different quadrants, you still take the absolute value. So absolute value is going to come up no matter what. Take the absolute value of the coordinates that you're going to use. But when they're in different quadrants, we add the absolute values. Bless you. Bless you. All right, so it says find the distance between -3, -5, and 2, -5. So if I sort of plotted, like if I made a little sketch of the coordinate plane here, let's just see where these points are. -3, -5 would be to the left 3 and down 5. 1, 2, 3, 4. So right here. -3, -5, and 2, -5. That would be to the right 2 and down -5. So these two points, are they in the same quadrant or different quadrants? Different quadrants. So we've got, I'm going to label them -3, -5, 2, -5. Now, what did our rule say? How do we do this if we have them in different quadrants? Okay, so first we take the absolute value of the values that we're going to use, which are the ones that are different from one another, right? -5 and -5, that's the same for both. So we need to use the values that are different. What is the absolute value of -3?
3.
And what's the absolute value of 2?
2.
Good. Different quadrants, what do we do with those absolute values? Different quadrants, we add. Different quadrants. Okay, different quadrants, we add. So absolute value of -3 plus the absolute value of 2. The distance between these 2 points is 5, right? We can double check by counting 1, 2, 3, 4, 5. So that is correct. There are 5 units in between -3 and +2. Let's do another one. Oh. Okay. What about the distance between 3, -2.5, and 3, -5? So let's start by, if we just plotted these, just to see, 3, -2.5 would be 3 to the right, and down -2.5. So between -2 and -3. And then we're going to 3, -5. So 3 to the right, down 5. 1, 2, 3, 4, 5. So that one would be right here. Okay, are these points in the same quadrant or different quadrants? Same. So what operation are we going to be doing? Subtracting. All right, so we're going to take the absolute value of the numbers that are different. So our 3's are the same. We don't want to use those. We're going to use the different numbers and take the absolute value. What's the absolute value of -2.5? Good, 2.5. What's the absolute value of -5? 5. So remember, when we subtract the bigger number minus the smaller number to find the distance. 5 minus 2.5 is what? 2.5. 2.5. So the distance between these 2 points is 1, 2, and then a half of a unit. So 2.5. It says the vertices of a secret chamber are -8, 10, 4, 10, 4, 2, and -8, -2. Okay, so it's got 4 sides. And it asks, what is the perimeter of the chamber? So if each coordinate is 1 meter, each little unit, each little square in our coordinate plane represents a meter, what is the perimeter of the chamber? Well, let's start by graphing it, because then we can figure out the length of each side and find the perimeter. And how do we find perimeter? Someone tell me with your hand up. Colin? Perimeter?
Wait.
I got this.
Mia?
It's adding a
Yeah, I forget.
No, Mia's got it. What is it? Mia, what do you do?
You add all of those up together.
All the sides. You add every side together. That's 2 times the length plus 2 times the width. But here we go. Let's graph this first. First we have -8, +10. So that's going to be way down, way up here. -8, 10. That's okay. Just estimate in your notes. Yeah, you can watch. Oops. Then we have 4, 10. I don't know.
I thought we were going by 6, man. I thought we were going by 12.
Okay. Then, oops. 4, 2. And finally, -8, 2. Yep. Oh, yeah, you're right. I did. Thank you. Let's put it right here. All right. Shh. To make this a polygon, I would connect my points. It's a rectangle. Okay, the perimeter. Shh. We need to find each of these distances. Ladies and gentlemen, your voices should be off. What is the distance across the top here? From -8, 10 to 4, 10. How far is that, Colin? Sam, 12. Shh. The absolute value of -8 is 8. These are in different quadrants. You have to add the absolute values if they're in different quadrants. So the distance, the length of the top is 12, because it's 8 units from -8 to 0, 4 units from 0 to 4, which is a total of 12. So my bottom length is also 12, right? And then what's my height? How far is it from one to the other? Edna? 8. Very good. From 2 to 10, these are the same quadrant, so we just subtract 10 minus 2. And it's the same on the other side. To find the perimeter, we add them all together. 12 plus 8 plus 12 plus 8. Right? 12 plus 8 is 20 plus 20. So the perimeter is 40. And it told us they were meters, so we would write that in. Meters. 40 meters.